In this video tutorial, I will explain how to implement multi-tenancy in AwareIM. First of all, what is multi-tenancy? Let's say you have developed your application and you want to host this application for your clients in the cloud. Let's say that each client is a company with many different users. Each user of the company will be logging into your application, so you can have many different users representing different companies. You are running the same application for all companies, but obviously you want each company to only see the data for this company and never see the data belonging to some other company. So essentially you want to partition your application for multiple tenants, where each tenant represents a company. How do you implement this in AwareIM? There are two completely different approaches for this, each having its pros and cons, which we will discuss in this tutorial. Which one you choose depends on your specific circumstances. The first approach is called multi-business space approach. With this approach, you allocate a separate business space for each tenant and import the same application into each business space. Whenever a new tenant or company signs up, you create a new business space, import your application into this business space, and publish this business space. You then give users of this tenant a URL to log in that includes the name of the business space, for example this URL. With this approach, AwareIM automatically guarantees that each tenant will only see the data that belongs to this tenant and never to any other tenant. This is because with the multi-business space approach, data of the tenant is stored in their own database tables. Moreover, when you create a new business space, there is an option to allocate this business space in a separate database. This option here. In this case, data for each tenant will be stored in a separate database. This is really easy to implement. What are the advantages and disadvantages of this approach? The advantages are: no changes to the application are required. It is easy to manage data for each tenant. Because data for each tenant is stored in separate database tables or even separate databases, you can easily back up and restore data per each tenant independently. If something goes wrong with the data of a tenant, other tenants are not affected. You can restore data for the affected tenant only. The disadvantages are: it requires a lot of server resources. If there are many tenants, a limit can be reached quickly and another server needs to be added. It is difficult to create an administrative view of the system that can collect statistics across different tenants, because data is stored in separate applications. It requires manual steps to create a business space, import the BSV, and publish when a new client signs up. However, these steps can be automated by a plugin. Also, future versions of AwareIM will include the functionality to do this automatically without a plugin. Let's now talk about the second approach to multi-tenancy, called single business space approach. With this approach, you only have one business space for all your tenants, and support for data partitioning between the tenants is built into the application itself. Let me explain first how this is done, and then we'll discuss the advantages and disadvantages of this method. In order to support this approach, you need to make some changes to your application, and I will explain what they are. Let's look at a very simple application that manages purchase orders. In this application, we have the company object that represents the tenant. For now, it just has the name attribute. Then we have users. We will represent administrators of the system using the standard regular user object, and tenants will be represented by the company user object. We also have the customer object, representing customers of the tenant. The order is for a particular customer. And of course we have the purchase order object for a particular customer and the order consists of one or more line items. And then, of course, we have the line item object that belongs to a particular order. Let's now add support for multi-tenancy to this simple application. First of all, we need to make sure that for every instance of the object, we can determine the tenant that this instance belongs to. Let's start with company users. They belong to a particular tenant, so they must have a reference to the company object. Let's add this reference. Then there is the customer object, which is also specific to a particular tenant. So we add the reference to the company object inside the customer as well. What about the order object? The order object is for a particular customer, and the customer is for a particular tenant. This means that we can deduce the tenant for the order from its customer, so we don't need to add a reference to the company object to the order. This is very important. If a tenant can be deduced from other references, the reference to the tenant doesn't need to be specified explicitly. The same applies to the line item object. A line item always belongs to the order. The order is always for a particular customer, and the customer always belongs to some tenant. So again, we can deduce the tenant for the line item object, and we do not need to add it explicitly. And what about the regular user object? Well, this object represents administrators of the system, and they do not belong to any tenant. Now we need to make sure that the reference to the tenant is correctly initialized for every object where it is defined. We have two such objects, company user and customer. Presumably, users of the tenant will be created by the administrator of the system when a new tenant signs up. It is also possible that users representing a tenant will be creating other users for this tenant, but let's not consider this scenario for now. So when the administrator creates a user for a tenant, he must explicitly specify which tenant it is by selecting the tenant from the list of available tenants. So in this case, we just need to add the company object to the form of the company user. I will not be doing it here, it is quite straightforward. What about the customer object? Customers will always be created by the users representing the tenant. We don't want them to explicitly select their company. It should be done by the application automatically, since the application already knows the tenant of the logged-in user. So we will add a rule to the custom object that sets the tenant of the customer from the tenant of the logged-in user. And the rule will look like this. If customer company is undefined, then customer company equals logged in company user company. So now we made sure that for every object in the system, we know the tenant that it belongs to. The only other thing we have to do is make sure that each tenant only sees the data that belongs to this tenant and not the data of other tenants. One approach to do this would be to build this protection into all queries used in the application. For example, if there is a query that returns a list of customers, it would look like this. However, there is a much simpler, more secure, and more elegant way to do this. Use the protection rules. Let me explain what I mean. First of all, your application obviously needs a special access level, or access levels, which will be assigned to users representing the tenant, as opposed, for example, to users representing administrators of the system. Let's add this access level and make sure that company users are initialized with this access level. We'll call it tenant, and the initial value for the company user will be tenant. Now we will add protection rules to all relevant objects of the application. Let's start with the customer. Our protection rule will look like this. If logged-in company user company is not equal customer.company, then read protect customer from tenant. This means that if the tenant of the customer is different from the tenant of the currently logged-in user, this customer will not be visible. And this will only apply if the current user has tenant access level, which means that this protection will not work for system administrators, but will work for company users. Let's say we have a query that returns all customers. If this query is run by the administrator, it will return all customers. But if it is run by a company user, it will only return customers that belong to the same tenant as the logged-in user. So this way, we can write all our queries everywhere without worrying about tenants. Similarly, for the order object, we will write the following protection rule. Note that here we use purchaseorder.customer.company to get to the tenant of the order. And similarly, for the customer user object, we will write the following protection rule. Do we need to write the protection rule for line items? We could, but line items always belong to a particular order, so they will probably always be viewed from that order, and there will be no special queries for line items. If our application enforces this, we don't really need to add protection rules to line items. And that's all we have to do to enable multi-tenancy in our application. Let's now consider advantages and disadvantages of the single business space approach. The advantages are: there's no need to do anything when a new tenant signs up. It can handle many tenants. There's virtually no overhead for the server for each tenant. It is easy to create an administrative view to look across different tenants, since all tenants are in the same database. The disadvantages are: it's difficult to back up and restore data for a particular tenant. If there is a data problem for one tenant, it can affect other tenants as well. So which approach you choose, single business space or multiple business space, depends on your specific situation. If you don't have too many tenants, or if you are happy to add additional servers for extra tenants, and you don't really need an administrative view across different tenants, then probably multi-business space method is the most appropriate. Otherwise, use the single business space approach.